This is Morten from Inkish. I am here at Highcon's new headquarters in Israel, and it's amazing to see. First of all, there's a lot of interesting technology here, and of course, always great people to meet. Arnon,
Nice to see you, Morten.
good to see you. I guess this is your baby, right?
Yeah, this is
And you're getting ready for drupa.
absolutely
And busy.
very busy.
And with a system like this, you have constantly been developing technology that makes it more easy and more productive for converters to both in the folding carton but also in the corrugated, right? What is new about this system?
So in a nutshell, the Beam 3 boasts 50% productivity enhancement relative to the Beam 2. To put it in numbers, we can say that this system can run on average 10 jobs of 1,000 sheets per shift.
So basically what you say, this is a system that is super smart for companies that have short runs, that have variable data, that have all these kind of things. Before we started the camera, you said that you're building on 3 pillars
Right.
that are interesting in understanding
Right.
how Highcon is thinking the future, right?
Correct. So when we look at productivity increase, it's not only about the system, it's not only about the system speed, especially in this market of short runs, we're looking at the shift. We're looking at throughput, covering the whole shift. So we're looking basically on 3 pillars when we're developing and providing this solution. The first pillar would be, of course, the system speed. We've increased through software and hardware enhancements the speed by 15%. Okay, the second pillar, which is very important for these short runs, is the setup time. Because in this kind of business, we want to make the setup to production ratio a good one. So we looked at the setup time, we made improvements in the software, and we've also taken out the rule writing, the crease writing from the system to a system which we call the Beam Writer. So we are able to write the creasing rules in parallel rather than in serial. So this saves us an additional 25%, or increases the productivity by an additional 25%. Okay. In addition, we've also added software on the system where the operator can fix mistakes while he's on the system without going back to the pre-press or the designer. We've also added a smart software that the input would be the job details, the substrate size, type, grammage, and it will predict the setup. So we took a big chunk of the setup of the system, which takes time and complexity. We automated this, and we have improved the setup time and reached improvements also in the accuracy and quality of the output.
One of the things I was thinking, because I mean, in a market that produces corrugated and folding carton, I guess that integrating with some of the existing solutions in the market like ESCO and hybrid, is that something that you also do now? Or?
Absolutely. So when we're looking at a full shift at the throughput, so the workflow is essential here. And I think it might be different than what most converters are used to, because when we're looking at a workflow for short run production, it's very fast, it's very intensive, and there's little room for mistakes. So we're putting our investments and our research into this, and we've partnered with industry leaders like ESCO Phoenix and hybrid software, and we've added capabilities for integrating to third party. So it's very important for us to allow further automation, for example, automated nicks and automated strip lines that are done through the pre-press process while the job is reaching the machine.
Shouldn't we take a walkthrough of the machine so I can learn a little bit from you?
Sure, absolutely.
Great. Let's go and see, right?
So this is the Beam Writer. This is a new system, and it's basically the Dart, which is the proprietary technology of Highcon, where we write the creasing rules. The layout file, the die line, is uploaded into this system. And this is where we are doing the writing. It's similar to 3D printing. We're extruding a photopolymer, which are the crease rules, and then curing them by UV.
It's funny because I was about to say 3D printing, because it is a 3D printing process, right?
It's actually a 3D printing process. It's developed by Highcon, and it's very sophisticated, because if you think, okay, crease rules, okay, but there's a lot of variety of substrate types in the industry, okay, grammages, thicknesses. So not every crease rule will be sufficient for all. So we also have a very, let's say, specific capability for configuring the rule heights. So according to the substrate type I have, I can make the rules higher, lower, according to the grain direction, across grain direction, and it's all done through the software in a matter of minutes.
I can't help think about, because I mean, when Highcon years ago started going into digital finishing with lasers, I mean, you had to break down a folding a packaging product into all the tiny little segments, because I mean, having the ideas of making a 3D printed dart is fantastic. Figuring out how you can make sure that the lasers are accurate. I mean, it's been a lot of R&D, right?
This is exactly one of the most exciting things for me working at Highcon, because it's truly a multidisciplinary technology company. Yeah. We have the chemist group, chemist development for the chemistry of the crease rules. We're also manufacturing this in-house. We have the lasers and the optics and the scanners and the controlling of all of this and the software that surrounds all of this. And we have the integrated stripping area. So this is very fascinating system to work.
Just move a little bit back, because you said that you could do things. I mean, obviously the sheets are printed, right? So right now we get the die information from and the folding information and everything we need to know. So here on the beam writer, basically what you see here is that you said that the colors on the design represents different types of things that you need on the dart, right?
Exactly. So basically, what we see here, this is a layout, okay, with the imposed die line. In this case, the red lines would be the laser cutting, and the blue and green lines are the crease rules. And the blue and green lines are what the dart system are writing on the foil.
And this is, I mean, if you were like in an analog world, this is what you would have done with small knives and a lot of tooling and a lot of preparation setting up the form, right?
Yeah. On the analog, where this could take hours to days, it takes us 10 minutes automatically, no tooling, no need to be a professional with experience.
And just to make sure that people understand that this functionality was previously built into the Beam 2. But now, since you have made it offline, it basically means that this machine can continue doing what it is best at, and it is not limited by the time that you need to create a dart, right?
Exactly, yeah. Exactly.
So that's part of the productivity game, right?
Exactly.
Okay, so here we have the Beam, and that is, I mean, you already told a lot about the fantastic improvements you've done. So just to finish this one, you take the film with the dart on, right, and then you mount it inside the machine here, right?
Exactly. So I can create as many dart foils as I want with the creasing rules, put them aside when I'm ready. Then I move on to the machine.
Is it easy to mount, or? Oh, okay.
Yeah, mounting takes 2.5 minutes. Okay. We take off the previous, this is a classic changeover. Yeah. I would take out the previous job. Yeah. Place in the new job. So take between 2 to 3 minutes, and I'm ready to go.
Smart, right? And then you have the pallet is already loaded and ready?
The pallet is loaded on the feeder. Yeah. We have a short setup for the feeder. And we can basically go through setting the rest of the job. So we already have the crease rules, and then we can continue to the user interface.
Yeah, because it looks, of course, I mean, you have the nice design, so it looks similar, but it is different here, right?
Yeah,
because now here you control the laser cutting and the nicks and all the things that you need in order to, and the stripping areas in order to make sure that you have something that is workable afterwards.
Yeah,
right?
Exactly. So we have some steps in the setup. So the first thing, we would set up the laser settings to have them accurate, to have them in the high performance and good quality. And the next step, if necessary, we also have the options for the operator to place the nicks. If he sees there is a mistake or something, he can change the nicks location, the nick sizes, he can add strip lines, and there's a good solution for last minute editing. You know, there's something in analog which you call a die rework. If something doesn't go very well, then you take it out and you hammer it or you slice it. But in our case, it's all in the touch screen.
Please don't hammer this screen, right?
Exactly.
So how much can you do here? I mean, do you ever have to go back to pre-press, or can you do most of the things that gets into the production
So this is
environment?
one of the improvements, because we on the previous version we didn't have all of these features, and sometimes in some cases you have the pre-press, he has the experience and the design or everything, but it goes to the system. You might need some fixing to do. Maybe the nicks need to be larger. Maybe there are too many nicks, something like this.
You can set that on.
So we
on
had
the
to
screen.
go back to the designer and the pre-press to do this, and we would have these iterations. But now the operator, who knows exactly what he needs, he can do this on the system.
Plus, you said that the system was also smarter of identifying itself where you need things.
Exactly.
Right? Yeah.
So there's a bulk inside the setup process where we need to perform some iterations, okay, to match, to get the best quality and accuracy. And it's because you have many subsystems that are handing over the paper and everything. So what we've done, we've developed a very sophisticated software where we input the substrate size, the type, the thickness, the grammage, the density of the crease rules, and it will automatically set up the settings that will give the best results.
I mean, so the crease rules are basically now, and everything is set up, so basically the two systems talk together to make sure that you have something that is production ready.
And what I was mentioning, we took this bulk, which was also time consuming and also complex. We took this out, automated it, so now it's even easier to use this system.
I was thinking, now with the Beam 3, can you get the Beam 3 where you have the dart built in still, or you need to have the beam rider always when you buy a Beam 3?
Oh, we have the option. The beam rider is as an option. Okay, you can start off with only the Beam 3, and later on you can add the beam rider as an option.
The reason I'm asking is because I've seen some press releases that you actually have many customers that have more than one machine.
Right.
And I take that it's a huge advantage for them, because now you have a machine that can work more efficiently and basically have a lot of time on the beam rider to just create darts, basically.
Exactly.
Right? So when you're in a
Creates darts for the
multiple
rest of the
setup, it
machine.
is even
Exactly.
smarter, right?
That's the idea. We're thinking big. We're thinking about mainstreaming this market of short run packaging.
I guess it's totally fair to say that you want to sell as many as possible, right?
Absolutely,
Of course.
and I think we will.
You will, yeah, definitely. Let's take a look inside the machine. You said there were some hardware improvements. It's still a laser that is running it, of course, right?
Yeah, it's still the lasers. Yeah. We made quite a few hardware improvements. You know, after analyzing the customers, the quality, everything that we saw in our installed base, we saw that we can make improvements in order to make the handling system more accurate. Okay, and then we have an overlay of software that finishes like the last mile, that brings the whole system to the exact quality results that we like.
And that leaves us, now we get to the stripping, and that is the inside stripping, right?
Exactly.
Yeah.
So we basically, you know, Highcon took the analog die cutting process and we split it, like you mentioned before. So we took the creasing on one station,
atoms, right? Yeah.
laser, and we also eliminated the need for stripping tools. And we have this internally, a stripping system that removes all the internal bits and pieces that remain. So the output is basically the products with a surrounding blank.
And the surrounded blanks, that where we basically say that you have blanking lines that can
Stripping
be
lines,
stripping
yeah,
lines that can
exactly.
be added to it. And that is basically when you have the delivery system. Now we're going to see the sheet that has been
Right.
Yeah. So now that is ready for. So you just explain. So these fine insides, they have been stripped inside
They have
the machine.
been removed.
Yeah.
Okay, no stripping tools, no cost or time for creating the stripping tools. These were removed internally.
Yeah. And just look at how fine the creasing lines, because I think that sometimes that converters have been a little bit, let's say, are the dart good enough, right? But it is actually
They're very fussy.
good.
It's very good. Yeah. Our customers are running these their products through folder gluers. The folding force is right on spec. So we're very proud of the quality.
Yeah, and then when you talk about the outside, this is the stripping line. So basically, here you have.
Right. So our next station, the next station would actually be to remove the outer blank.
Yeah.
And in order to make it easier for this process, we can add stripping lines. So it's easy, very easy to just take out the outer blank.
Yeah.
and strip the full of it.
And I mean, a lot of these things is that processes that you also do in analog, but because you have it inside a system like the Beam 3, it is basically a more finished product you get out of the machine, right? You don't have too many external processes to do the same work. Or is that not right?
I didn't understand.
No, I was just thinking that because I mean, when I see these sheets, they already stripped, right? You have the outside here is already prepared for
We
it.
have the outside.
Yeah. So it's easy to get this job into the folding gluer, basically.
Absolutely.
Yeah.
Right afterwards, they go straight to the folding gluer.
And a finished product could look like this, right?
Yeah.
Are you trying to tell us that it's about lunchtime now or coffee time? Or?
It could be. I mean, this will always be good for the blood.
And I think it's funny that you have made something called the dart, right?
Yeah, this is the dart.
Maybe it should be the tart.
Good one. I'll take that.
Fantastic.
And you know, this is one of the challenging parts of packaging because the quality, I call it binary.
Yeah.
It either works or it doesn't.
Yeah. And here it works, right?
It works.
Arnon, super great talking to you. Thank you very much.
Thanks a lot.